IR presents Data's Anatomy. Confusin Correlation with Causation. Dan and Daphne, data interns. On this episode, topic, correlation. Importance, understanding the interpretation of correlation.
Great way to end our data retreat. I feel like I learned a lot.
Yeah, my head is spinning with a ton of new ideas. We could look into predictive analytics, longitudinal tracking, dashboards, data visualization, and correlational analysis.
Whoa, Daph, pace yourself. You just said about 1,000,000 words that mean nothing to me.
Yeah, you learned a lot, all right. A lot of nothing, apparently.
You just wait. I'm sure I picked up something new I can bring back to the office.
Hopefully it's something more than that magic 8-ball you got at our last retreat.
Hey, my magic 8-ball's still more accurate than some poorly designed predictive statistical models.
Back at the office.
Howdy, Daph. I reckon I surprised you with my correlation analysis I done this morning.
What are you wearing? Wait, forget I asked. Actually, I was impressed by your analysis. Can we talk through your results?
So I was looking at the relationship between the number of visits to the tutoring lab and final exam scores.
Looks like there was an upward trend.
Yep, as the number of visits increased, the final exam score increased. So you can say there's a moderate to strong positive relationship between the two variables.
Watch out, you did retain something from the data retreat.
Yep, I found out this cowboy hat makes me look 23% cooler.
Sure, just keep telling yourself that.
Anyway, I also looked at the relationship between the number of absences and final exam score. There was a negative relationship. Final exam scores decreased as the number of absences increased. Thus, my results have proven that visiting the tutoring lab causes higher grades and being absent a lot causes lower grades.
Wait, hold on there, Dan. Saying one variable causes another is a really strong statement. You've got the idea that correlation measures the strength of the relationship between two variables, but you're confusing correlation with causation. There are many reasons why two variables might be related. Yes, it is possible they are related because one is causing the other. But let's consider an extreme example. Say we have a consultant, call him Stan, looking at some data from a local elementary school. Stan happens to plot the number of vocabulary words a student can recognize against their height. He notices a relationship. Taller students recognize more vocabulary words. Do you think getting taller causes a student to know more vocabulary words?
Nah, that makes less sense than a polecat in a prairie dog hole.
Okay, but why might height and number of vocabulary words be related?
Well, older students are taller and likely know more words.
Right, so the two variables are related simply because they are both related to a third variable, age. Again, as you can see by this example, there are other reasons two variables can be related. So in sum, two variables might be correlated because one variable is causing the other, two variables are related through a third underlying variable, both are changing in the same direction over time, the variables are simply related by chance.
Back at the office.
Howdy, Cowboy Dan. I'm back from lunch and I'm fixing to do my own analysis. So just sit back, relax. I'll show you how it's done.
Them's fighting words. Guess we'll settle this with a good old-fashioned calculator draw. Quick, 1024 times 352. Ready? 3, 2, 1, calculate!
To be continued. Next time on Data's Anatomy, summarizing state reporting.
This is Dan,
And Daphne.
signing out. Gotta run. See you next time.
IR, slamming the data.
For more information, go to our website. Be sure to check out our existing reports and other helpful videos.
Questions? Contact us at IR.